Welcome to Hardly, where books turn into 3 stories, refreshing your knowledge in minutes. Today, we study together Matt Strassler's book, Waves in an Impossible Sea, how everyday life emerges from the cosmic ocean, in which we probe into how the unseen forces of the cosmos shape the tangible realities of our daily lives, revealing the hidden connections between physics and existence. Matt Strassler is a theoretical physicist, blogger, and writer whose research often takes him to the Large Hadron Collider. Don't go away. Hardly, the editor, will be right back with the story. Today, we dive into 3 captivating stories that illuminate how unseen cosmic forces shape our everyday realities. Our journey begins with the story of Galileo's ship, where we explore the concept of relative motion and how it can shape our perception of reality. Next, we move on to Einstein's playground, where the strange properties of light and gravitational waves challenge our understanding of the universe. Finally, we end with the tale of the Higgs field, where we uncover how a mysterious entity permeating all space gives mass to the particles that make up everything around us. Galileo's ship, the illusion of motion. Imagine being below deck on a large ship, moving smoothly across the sea. You're inside a cabin, surrounded by solid walls, unable to see or feel the waves outside. You might be tempted to believe you're completely stationary. This was the scenario Galileo presented to illustrate the principle of relativity. A person below decks on a smoothly sailing ship cannot hope to determine whether the ship is in motion, or, if so, what is its speed. In this experiment of thought, Galileo reveals a fundamental truth about our perception of motion. Within that enclosed space, devoid of external reference points, it is impossible to tell whether the ship is moving steadily in a straight line or is at rest. This story forces us to consider the nature of our own experiences. Just like the ship's cabin, our daily environment shields us from the relentless movement of the Earth through space. As we sit still in a room, seemingly stationary, we forget that we are on a planet hurtling around the sun at 67,000 miles per hour. Our senses deceive us, tricked by the stability of our immediate surroundings. This concept is not just a philosophical musing. It has practical implications. For instance, when pilots navigate a plane, they must rely on instruments rather than their senses to determine the plane's position and speed relative to the Earth's surface. This need to use instruments reflects the same principle Galileo demonstrated. Without external points of reference, our perceptions can be completely misleading. As we finish this story, let's hold on to the sense of wonder that comes with understanding the relativity of motion, setting the stage for a deeper dive into the universe's more perplexing mysteries. Einstein's playground, the relativity of light and gravitational waves. Moving from Galileo's ship to the cosmic scale, we enter a new realm, Einstein's playground. Here, light and gravitational waves dance to their own cosmic rhythm, seemingly defying the very fabric of reality. Imagine a spacecraft traveling through the vast emptiness of space. No matter how powerful its engines, it can never overtake a beam of light or a gravitational wave. This story showcases the remarkable fact that unlike sound or water waves, light and gravitational waves cannot be surpassed by any object, no matter how fast it moves. Einstein realized this strange property of light waves and formulated his theory of relativity. He showed that the speed of light is a cosmic speed limit that no material object can exceed. Empty space is sort of like an ocean, and yet, in the end, it's not. There's something almost illogical about it. This notion turns our intuitive understanding of speed and motion on its head. In one striking experiment, scientists used lasers and highly sensitive equipment to detect ripples in space-time, gravitational waves, created by two black holes colliding billions of light years away. These waves traveled at the speed of light, stretching and compressing space itself as they passed by. For a moment, the entire Earth expanded and contracted, albeit by less than the width of an atom. Yet, just as with Galileo's ship, our senses were oblivious to this cosmic event. The instruments, however, detected it clearly, confirming Einstein's predictions from a century ago. This phenomenon makes us wonder, what other unseen forces are at play around us, subtly shaping the very fabric of our existence? As we ponder this, we are led to the next story, where the unseen becomes even more profound and perplexing. The tale of the Higgs field, the fabric of existence. Our final story brings us back down to the subatomic level, where the building blocks of everything we see and everything we are derive their mass from an invisible field that fills all of space. The Higgs field is an omnipresent, unseen entity that imbues particles with mass, determining their weight and behavior. Imagine walking through a field filled with tall, dense grass. The harder you push, the more resistance you feel, and the slower you move. This is analogous to how particles interact with the Higgs field. The more they push against this field, the more mass they gain, slowing down in their motion. The discovery of the Higgs boson at the Large Hadron Collider, LHC, in 2012 confirmed the existence of the Higgs field. This was not just a triumph of theoretical physics, but a revelation of how fundamental forces shape our world. One compelling analogy presented in the book compares the Higgs field to a crowd at a party. As objects move through it, the crowd slows them down, and that's how they get mass. Just as a celebrity entering a crowded room might struggle to move through a throng of admirers, certain particles interact more strongly with the Higgs field, gaining mass and moving more slowly. The story of the Higgs field challenges us to rethink our assumptions about what constitutes reality. For most of human history, we assumed that mass was an intrinsic property of matter, a fundamental characteristic that simply existed. The Higgs field suggests otherwise, proposing that mass arises from a deeper interaction with the fabric of the universe itself. It is a cosmic revelation that forces us to reconsider the nature of existence, not just in abstract terms, but in the very tangible reality that makes up our bodies, our planet, and our universe. Each of these stories, the relativity of motion in Galileo's ship, the cosmic speed limits revealed by Einstein's playground, and the mass-giving power of the Higgs field, unveils an unseen force at play in our everyday lives. They connect the distant, often incomprehensible realm of theoretical physics to the tangible experiences of our existence. Understanding these concepts allows us to grasp the universe's complexity in new ways, revealing a world where the invisible is constantly shaping the visible. As we conclude this exploration, we are left with a profound realization. Our daily experiences are intricately woven into the grand tapestry of the cosmos. where every moment, every movement, and every particle is part of a much larger, unseen narrative. As the editor of Hardly, by understanding these concepts, we can begin to reimagine our place in the universe, where future explorations might not just be about reaching distant stars, but understanding the very fabric of reality itself in more profound, creative ways. In reflecting on how the unseen forces of the cosmos shape our daily lives, we've uncovered a hidden world of motion, light, and mass that lies beneath our everyday experiences. We've explored how Galileo's principle of relativity shows us that motion is a matter of perspective, how Einstein's theory reveals the speed of light as an unbreakable cosmic speed limit, and how the Higgs field gives mass to particles, fundamentally shaping the fabric of reality. One final story that stands out is the discovery of the cosmic microwave background, CMB, radiation, which serves as a relic of the early universe. Imagine an ancient photograph capturing the universe as it was nearly 14 billion years ago. This faint glow, spread uniformly across the sky, is the afterglow of the Big Bang, stretched and cooled over time. It acts like a cosmic backdrop to all our activities, a reminder that everything we do is occurring within a universe that has been expanding and evolving for billions of years. Scientists, using precise instruments, have mapped this radiation, finding tiny fluctuations that provide clues about the universe's structure and evolution. This story is a testament to the unseen forces constantly at work, shaping not just the grand cosmos, but the very conditions that make life possible on Earth. Through these stories, we understand that our daily lives are deeply connected to the invisible workings of the universe. The forces we cannot see, whether gravitational waves, light, or the Higgs field, are the very forces that shape the reality we live in. As the editor of Hardly, by recognizing these invisible forces, we can better navigate our world and perhaps even anticipate the next big leap in understanding the universe around us.